Alright, here is my Physics 2211 Lab 4. The purpose of this lab is to observe and measure the motion of a mass swinging in an arc while oscillating on a spring. My goals in this lab is to compare the predicted motion, which is found through the utilization of GlowScript, and the observed motion, which is analyzed through the Tracker app. Additionally, I sought out to determine whether or not the model system satisfies the principle system, mass, spring, earth, surroundings, nothing. Some of the key physics principles that we'll be using is Newton's second law, the energy principle, and some other key equations like the gravity being negative 9.8, kinetic energy, spring force, gravitational potential, and spring potential. Here you can see my y and x versus mass graphs where I observed the motion in the Tracker app and set a calibration stick and my x and y coordinates. My initial conditions for this lab was my mass is 0.402 kilograms, the initial velocity is 0 meters per second, initial position is negative 0.125, negative 0.310, and my time frames were 0.095 second intervals, with the last time of observation being at 9.497 seconds. Here you can see how I solved for t by using the equation t equals 2 pi square root of m divided by k, where I found t is equal to 1.5237, and then I solved for k and got k equals 6.83 newtons per meters, and then I solved for the relaxed length, which I got to be 0.1232 meters. Here you can see the specific lines of code that I changed. So the differences between my observed data and computational data are seen in the two graphs, and some errors that could have occurred when I was trying to find these was that in reality the system is not isolated from the outside world, therefore other forces are acting on the mass, and there could have been errors in tracking of the center of mass. Now the big question is, was the energy principle satisfied? Yes. In order to have a principle be satisfied, the change in energy must have been equal to the work done by the surroundings. Because there's no work being done on the closed system model, the change in energy must be equal to 0. On my graph to the left, you can see that delta E, which is the change in total energy in the system, it does remain at a constant 0. This is because the kinetic energy is equal but opposite to the total potential energy of the system. And here is how I found my comparison of oscillation periods. In the y direction, I found t equal to be 1.651 seconds, while in the y direction, I found t to be 1.5237 seconds. In the x direction, I found k to be 5.62 newtons per meter, and in the y direction, I found k to be equal to 6.83 newtons per meters. And here is a link to my code. Thank you so much for watching.